Okay, so like I said, there are situations in this lesson where the graph can cross the asymptotes, okay? And we'll determine what makes that true or not true. So we want to determine the domain and range and the x and y intercepts. So we have f of x is equal to x divided by x minus 2. Okay, so do we have any vertical asymptotes? Okay, so we have a vertical asymptote at x is equal to positive 2. So remember, the vertical asymptote has to do with the denominator. Okay, now we're going to get into the concept of horizontal asymptotes. Okay, so if the degree of the numerator and the degree of the denominator are the same, all you are doing is taking the coefficients that are in front of those variables and dividing them by each other. Okay, so in this case, the numbers in front of both of the x's, they have the same degree, but they have no coefficients, so they're just a magical 1. So we do 1 divided by 1, which gives us just 1. Okay, so we have a horizontal asymptote at y is equal to positive 1. Okay, so if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is 0. Okay, if the degree of the numerator is exactly one greater than the degree of the denominator, there is an oblique asymptote, which is slanted. Okay, and if the degree of the numerator is equal to the degree of the denominator, we want to take the ratio of the leading coefficients in the numerator and denominator and find out what the ratio is. Okay, so for this graph, we have a vertical asymptote at x is equal to 2. And a horizontal asymptote at y is equal to 1. Okay. So what we need to do now is figure out our key points, okay? And what were the key points that we need to figure out with reciprocal functions? So the horizontal asymptote has to do with the degree in the numerator and the denominator. So if the degrees are the same, so in this case, x is in the numerator and x is in the denominator, so the degree is 1. If the degrees are the same, you just take the ratio. So all you're doing is dividing the coefficient in front of the x in the numerator and dividing it by the coefficients before the x in the denominator. Okay. If the degree in the numerator is less than the degree in the denominator, then you have a horizontal asymptote at y equals 0. Okay. And if the degree in the numerator is greater than the denominator, then you have an oblique asymptote, which is something completely different, which you're not going to worry about right now. So like Matthew said, we need to figure out the points of positive and negative 1. Okay? So we're going to figure out our points. So let's try negative 1. So we have negative 1 is equal to x over x minus 2. So we're going to cross multiply. So we get negative 1 times x minus 2 is equal to x. Now we're just going to FOIL. So we get negative x plus 2 is equal to x. Leave x on one side. So we get 2 is equal to 2x. Divide both sides by 2. We get x is equal to 1. So we get the points of negative 1 at 1 and negative 1. Okay? So we're going to have a point here. So now what we need to do next is check where we get positive 1. So if we get 1 is equal to x over x minus 2, we're going to do the same thing, cross multiply. Can negative 2 be 0? No. Okay. The reason why this doesn't work is because x minus 2 is already a vertical asymptote. Okay. So that means that the graph is not going to cross at x is equal to 2. Okay. So that is the reason why we can't have the points at 1 is because we have a horizontal asymptote at y is equal to 1. Okay. So for this graph, we know it is going to, if we roughly sketch it, it's going to look like this. And it's going to have a random point in this half of the graph as well. And if I show you what it looks like on Desmos, it'll look the same. So on Desmos, as you can see, you have the point 1 and negative 1. Okay, it never hits the vertical asymptote of x is equal to 2 and never touches the asymptote of y is equal to 1. Okay? So we have our asymptotes, we have a sketch of the graph. Now we need to determine the behaviors around the vertical asymptotes, the end behaviors, and check for crossings. We want to figure out our domain and range and the x and y intercepts. Okay? So we already figured out our vertical and horizontal asymptotes. So we're done with that part. Let's just do the easy things first. Do we have any x-intercepts in this graph? Okay. And the x-intercept is when y is equal to 0. Okay. So obviously my graph was a bit off. So the x-intercept is when y is equal to 0. Should we just set f of x equal to 0? So you get 0 is equal to x divided by x minus 2. We cross multiply and we're left with x is equal to 0. So we have an x-intercept at 0 and 0. Do we have any y-intercepts? Yep. And the y-intercept is going to be the same thing as the x-intercept. So it's going to be at 0 and 0 as well. So we're done with this part over here. I mean, I'm not going to make you guys suffer, but I don't mind. The questions are easy enough that you guys shouldn't have to use your notes, but if you do need them, that would be your last resort. So what would our domain and range be for this function over here? So our domain is XER such that what? X cannot equal 2. In our range, we have YER such that Y cannot equal what number? 1. Okay, so this is our domain and range. So now let's look at the end behaviors. So as x approaches negative infinity, y approaches what? 1. Okay, and because we have this horizontal asymptotes, as x approaches negative infinity, y approaches 1 from below, because it's coming from below that vertical asymptote, or the horizontal asymptote, sorry. And as x approaches positive infinity, y approaches what number? So 1, and from below or above? From above. So when we have a horizontal asymptote, this is what we're going to have to use now. So we're going to have to use from below or from above. Okay? So this is just basically where we're just using the visualization of the graph. So you can tell as x keeps approaching the negatives, y is going to approach closer to 1 from below because it's coming from the bottom up. Okay? And as the x's approach the positive infinities, y is going to approach 1 from above because it's going from the top and it's coming down towards it. So our end behaviors are done, and we do not cross the asymptotes at all. So to check for the crossing, okay, so to check for crossing of asymptotes, all we're going to do is we're going to take the ratio from the coefficients that are in front of the variable. Okay, so in this case, it was 1/1, and set that equal to our function. So x divided by x minus 2. Okay, and this looks similar to what we did. So at the end, we end up getting -2 is equal to 0, but that cannot happen. Okay, so that means there are no crossings at that point. Okay, or there are no crossings of the vertical or horizontal asymptotes. The next example will have an example of where it crosses, and I'll show you how to calculate that. So the last thing we want to do is we want to check the behaviors around the vertical asymptotes. Okay. So our vertical asymptote, we said, is that x is equal to 2. Okay. So this is going to be something relatively new. So we're going to check what happens when we approach 2 from the right and 2 from the left, okay? So let's see how I can explain this to make it easier for you guys. So if we're, let's just say, let me just erase these lines so they don't confuse you. So when we approach 2 from the left, we're talking from this point of the graph all the way to where it hits 2. This is approaching 2 from the left, okay? And when we talk about approaching 2 from the right, we're talking about going from the positive infinity all the way to our vertical asymptotes, okay? Or what we can simply do is just take numbers from the left of x values from the left of 2 and from the right of 2 to determine what happens to the function. So can somebody give me a number that is to the left of 2? So when I say a number that's to the left of 2, that means a number that comes before 2, so 1. Let's just take f at 1 is equal to x over x minus 2. So we don't necessarily have to calculate a number, okay? All we have to do is to determine the sign, okay? So if we sub in x for 1, we get a positive in the numerator and a negative in the denominator, okay? Which means that if we approach 2 from the left, these numbers are going to be approaching negative infinity, okay? Now somebody give me a number that's to the right of 2. So 3. So we'll check f at 3 is equal to x over x minus 2. So we get a positive sign in the numerator and a positive sign in the denominator, which means these values are going to approach positive infinity, okay? So the notation in which we are going to write this is going to be as follows. So we're going to write as x approaches 2 from the left. So we're going to denote a negative sign on the top right of 2. Y approaches negative infinity. And as x approaches 2 from the right side, y approaches positive infinity. Okay, honest question. How many of you are confused right now with this whole new thing of adding a horizontal and vertical asymptote? So we didn't do anything different, okay? The only thing we really added was what James said is the last part, the behavior around the vertical asymptote, okay? That's the only thing that's different in this lesson. So the reason why they do this is to figure out how the y values are going to react as they approach that vertical or that x value from the left and to the right, okay? So an easy way to do this was to do as I did to make it simple. So say our our vertical asymptote is x is equal to let's just say +1, okay? So I'm going to take a number that is to the left of 1, okay? Sub that in for x and see what sign it gives me. And that's going to tell me what the y's approach when it's coming from the left of 1, okay? And you're going to be doing the same with to the right of 1. We're going to be picking a value to the right of 1. So for example, 2. Okay, so we're going to be doing more examples of this. Hopefully it gets more clearer as we do the next one. Okay, so this one involves a quadratic. It's the same concept. Okay, so we'll just go through it step by step. So our example 2 is use key characteristics to graph the function g of x is equal to x squared over 2x squared divided by x squared plus 3x minus 4. Yeah, so if it was a negative over a negative, it would be approaching positive. So let's start with the easy part. Let's identify our vertical asymptotes, okay? So remember, our vertical asymptotes have to do with our denominator. So we have x squared plus 3x minus 4, okay? So obviously, to get our vertical asymptotes, we have to factor this trinomial. So if we factor this trinomial, what does it give us? So remember, we have a product of -4 and a sum of +3. So what two numbers multiply to -4 and add up to +3? Yep, so we get +4 and -1. So we get 4 times -1 gives us -4, and 4 plus -1 gives us 3. So we're going to get x plus 4 and x minus 1. So where are our vertical asymptotes located at? X is equal to -4 and +1. Okay, so let's start by plotting that out. So you have x is equal to 1 and x is equal to -4. So we did our vertical asymptote. Now we have to check for a horizontal asymptote. So is the degree in the numerator the same as the degree in the denominator? Yes, they both have a degree of 2. Okay, so we have x squared, degree of 2, and we have x squared, which is the highest degree in the denominator. Okay, it's okay, James. We all make mistakes. Don't worry about it. You'll get the next one. So what did I say? If the degrees are the same and coefficients are different, what do we have to take? Starts with an R. So we're going to take the ratio. And if we take the ratio of 2/1, what does that just give us? Two. So we have a horizontal asymptote at y is equal to 2. So by doing this next example, do you guys understand how to get the horizontal asymptote? So to get the horizontal asymptotes, if the degree in the numerator and the degree in the denominator are the same, you're just taking the ratio of the numerator and the denominator. Okay, so you're just essentially dividing the number that's in front of the x squared in the numerator and dividing it by the number that's in front of x squared in the denominator. So in this case, it was 2 and 1. So we did 2 divided by 1, which gave us 2. The 1 came from the value that's in front of the x squared in the denominator. Remember, if there's no value, it's just an imaginary 1. So now let's get a bit of more practice with the behaviors approaching the vertical asymptotes. Okay. So let's look at behaviors approaching vertical asymptotes. Let's see if you guys remember what I said prior to. Okay. So let's take a look at the vertical asymptote of x is equal to positive 1. Okay. So what two cases do we need to look at? Yep, so we're going to take a value that's to the left of 1 and a value that's to the right. So let's start with a value that's to the left of 1. So give me a value that's to the left of 1. Don't give me 0. That's just going to give me 0 in the numerator. Okay, so let's just take f at negative 1. So if we take f at negative 1, what sign does my numerator give me back? Positive or negative? So my numerator gives me back a positive. And if I put a negative 1 in the denominator, does it give me a positive or negative result in that denominator? Oh, Juliana, we don't use 0 because if you sub in 0 for the numerator, it's just going to give us 0 back. Okay, and you can't really determine if 0 is positive or negative. Okay, Adam, thank you. Your denominator is going to be a negative, which means it approaches negative infinity. So now let's take a number that's to the right of 1. So give me a number that's to the right of 1. Yes, that would be the safe option. Just go one more a bit. Or what some people usually do in this case is just take the vertical asymptote and subtract 0.1 so that it is to the left, and then add 0.1 which is to the right. But you can also use whole numbers, so it is up to you if you want to use the decimals or the whole numbers. But just don't use a number that's going to make the numerator or denominator 0. So we're going to use f at 3 because it's to the right of 1. So our numerator is going to be positive, obviously, and our denominator, is it going to be positive or negative? It's going to be positive. So that means this approaches positive infinity. Okay, so before we go to negative 4, let's just write our statements down. So as x approaches 1 from the left, y approaches negative infinity. And as x approaches 1 from the right, y approaches positive infinity. Okay? So now we're going to look at our vertical asymptote of x is equal to negative 4. So hopefully this way, you guys understood it better. I'm just taking it case by case and not just doing it all at once like I did with the first example. So now we're going to take our vertical asymptote of x is equal to -4. So what number is to the left of -4? So let's just take f at -5. Okay. And what numbers or what signs do my numerator and denominator give me? So we get positive over positive. So that means this is approaching positive infinity. Now we need to take a number that's to the right. So what's to the right of -4? We can use a number that we use in the first example. Or we can use -1, but both of them work. So let's take f at -1. So if we sub in -1 for x, what does my numerator and denominator throw back? Positive over negative, which means this approaches negative infinity. So now given what we concluded, we can now write our statements. So as x approaches -4 from the left, y approaches positive infinity. But as x approaches -4 from the right, y approaches negative infinity. So Juliana, so remember, any negative number that's squared is always going to give us back a positive, okay? So for example, in our numerator, we have 2x squared. So 2 times -5 squared is just 2 times -5, which is positive. And in the denominator, even though we have that -4 at the end, the result of subbing in -5 from just x squared by itself is still going to give us a positive number in the denominator. So is everyone starting to understand this a bit more? Okay. I just heard 3 people say yes. I need more responses, guys. 4 people do not represent the population of this class. It's basic data management. Yes, yes. Okay. If you're lying to me, you can just ask me a question after, in case you don't get it. So yeah, and you guys and cohort B can ask me questions tomorrow, and I'll probably take it up. So now that we know our behaviors approaching the vertical asymptotes, okay, now we need to figure out if there is a crossing of the asymptotes, okay? So remember the y values, how positive and -1 were very important. Okay, so this is where we're going to determine how this crosses the vertical asymptote, okay? Not the horizontal asymptote, sorry. So we're going to check now for the horizontal asymptote crossing. So this is where we see if the graph crosses our horizontal asymptote of y is equal to 2, okay? So to figure out if this horizontal asymptote, or if this graph is going to cross this horizontal asymptotes, all we're doing is setting our function 2x squared over x squared plus 3x minus 4, and setting it equal to our ratio. So what was our ratio that we came up with for our horizontal asymptote at the beginning? 2/1. Okay, so this 2/1, okay, this is going to be our y value, okay? Because we're figuring out if it crosses at a certain x value. So all we're going to do is we're going to cross multiply first. So we got 2x squared is equal to 2 times x squared plus 3x minus 4, which gives us 2x squared is equal to 2x squared plus 6x minus 4. Okay, we want to set one side equal to 0. So we got 0 is equal to 2x squared minus 2x squared plus 6x minus 4. So as you can see, these cancel each other out. So we're left with 0. Sorry, yes, it's 8. My bad. So 0 is equal to 6x minus 8. And then we have to isolate for x. So you get 6x is equal to 8. Divide both sides by 6. So when we simplify 8/6, what does it give us in simplified form? Four over 3. So we can say, therefore, the graph crosses the horizontal asymptote at 4/3 and 2. Okay, this is not going to happen all the time. Not all graphs are necessarily going to cross their horizontal asymptotes, but sometimes it does happen. Okay. So now we barely have any points for this graph, but we can use the behaviors to help us graph out this function. So we have a point at 4/3 and 2, which is 1.75, and 2, which is over here. What would our y-intercept be if we set x equal to 0? So our y-intercept is 0 and 0, okay? So this is why the behaviors at approaching the vertical asymptote is very important, okay? So as you can see, if we approach 1 from the left, it keeps going down to negative infinity. And if we approach -4 from the right, it still keeps going down to negative infinity. Okay, so based off those behaviors, remember this is only a sketch, we can assume that the graph between those asymptotes goes like this. Does that red graph make sense based off our behaviors approaching the vertical asymptotes? Okay, I got one person saying yes. Okay, so for sketching these type of graphs, this is where the behaviors approaching the vertical asymptotes come in handy, okay? So we found our y-intercept. We found it to be 0, 0. So when we look at our behaviors approaching the vertical asymptotes, when we approach 1 from the left, so when we approach 1 coming from this way, the y values keep getting more negative, okay? Now, when we approach the other vertical asymptote, when we approach -4 from the right, so when we approach -4 going this way, the y values get more negative, which is why that inside part of the graph looks the way it does. Because when you're approaching the vertical asymptotes from those sides, it keeps getting more negative. Okay, so now let's take that same concept, okay, and figure out how to graph the rest of this reciprocal function. So we know the graph only crosses the horizontal asymptotes on the right side of the graph, okay? So based off our behaviors approaching the vertical asymptote, so as the graph approaches 1 from the right, so as we go from the positive infinities all the way to our vertical asymptote of 1, the y values keep getting bigger, okay? So if we approach from the right, our y values get bigger. Does that make sense? Okay, normally we would not be able to cross that horizontal asymptote, but because we found the point where it crosses, we have to include that in there, okay? However, if we approach -4 from the left, so from the negative infinities, we approach -4, the y values go up, but we do not cross the horizontal asymptote. So does that part of the graph make sense now? So if I ever tell you to graph a reciprocal function like this, what are you going to be using? What's the most important piece of information you're going to be using to help you graph this graph? Yeah. So all we're doing is we graphed this reciprocal function just based off the behaviors of the graph approaching its vertical asymptotes, okay? And that's going to help us graph these types of reciprocal functions, okay? So now with that said, now all that's left is to determine the end behaviors, okay? So I'm gonna erase the horizontal crossing part. Okay, so based off the graph, let's just look at our end behaviors. So as x approaches positive infinity, what does y approach? Y approaches 2 from above or below. Remember, it crosses the horizontal asymptote. So if it crosses the horizontal asymptote, that means it's going to be under it, which means it is also the same word as using below, okay? And as x approaches negative infinity, y still approaches 2, but it's going to approach 2 from above. So is it starting to make more sense now than it was in the beginning? Okay, perfect. So we have 2 more examples. They're not hard, okay? So we want to graph h of x is equal to x minus 3 over 2x minus 6. So what can we factor from the denominator? 2. So we get 2, bracket, we're left with x minus 3. So what do we do with those x minus 3's in the numerator and the denominator? Do they cancel each other out? So they cancel. So we're left with 1 over 2. Okay? So we have a vertical asymptote. Okay? So we have a VA at, what was our denominator if we simplify it? What's our vertical asymptote? 3. So we have a vertical asymptote at x is equal to 3. And what is our function? Y is equal to 1 over 2, right? So this is our h of x. So it's equal to 1 over 2. So when we have a function that is just equal to a constant, are we going to get a vertical or horizontal line as the graph? So we're going to get a horizontal line as our graph, and our horizontal line is going to happen at y is equal to 1/2, okay? But what's going to happen at x is equal to 3? So we have y is equal to 1/2. At x is equal to 3, there's going to be a hole in the graph, and then it's going to continue. Because Juliana, if we sub in x is equal to 3 for our denominator, what does it give us? 0. And any number that is divided by 0 is also what? It's also undefined, okay? So when we have a numerator and when the denominator cancels out, okay, at that specific point is where there's going to be a hole in the graph, okay? So because there was an x minus 3 at the numerator and an x minus 3 in the denominator, because they canceled out, at x is equal to 3, there will be a hole. So that will be the general rule for any time you have to cancel out an expression from the numerator and the denominator. That means there's going to be a hole in that graph at that specific point. So last but not least, we want to describe the end behaviors. That is, as x approaches plus and minus infinity of each function. Okay? So what would our horizontal asymptote be for 2x over 4x minus 7? So remember, look to see if, yep, 1 over 2. So the degrees are the same for both x. It is 1. And then all we're doing is taking the ratio. So 2 divided by 4, which gives us 1 over 2. Okay. So somebody give me a x value that approaches positive infinity. Give me a big one. Okay, let's take 1,000. So we'll take g at 1,000 is equal to 2x over 4x minus 7. The reason we're picking such a high number is to determine whether the graph is going to approach positive or negative infinity. So the higher the number we pick, the better we are to identify if it's positive or negative infinity. Because if we just take, let's just say, a small number, we can't really justify the behavior of the graph going forward. So this is just equal to 2,000 divided by 3,993, which gives us 0.501. Is that greater than 1/2? Which is greater than 0.5. And all this implies is that as x approaches positive infinity, y approaches 0.5, which is the horizontal asymptote from above. Okay? So now we're going to do the same thing with the negative infinity. So give me a negative number that's close to negative infinity, or like a big number. Okay, let's just use, we can use negative 2,000, but to make it easy, let's just use negative 1,000. So just to do the opposite. So we take g of negative 1,000 is equal to, we sub it in, you get negative 2,000 divided by negative 4,007, which is equal to negative 0.499. Is that greater than or less than 0.5? Oh, so Adam, to determine if it's above or below, we're just seeing if the number we're subbing in is bigger than or less than our horizontal asymptote. So for example, when we subbed in g for 1,000, we got 0.501, which is bigger than 0.5, which is our horizontal asymptote. So that means that as x approaches the positive infinities, y approaches 0.5 from above. Okay? And with this last one, we get, positive 0.499. And for the last one is, as x approaches negative infinity, y approaches 0.5. And because the result is less than 0.5, it approaches it from below. Yep, so greater means above and less means below. So now let's take a look at the next example and see if our method holds true. So what is our horizontal asymptote for 3 minus x over 2 plus x? No, we're looking at the numbers that are the coefficients in front of the variable. So yes, Joseph, thank you. It's negative 1 over 1, which is just y is equal to negative 1. Okay, so now we're going to take numbers. We're going to use the same values. So we're going to take h at 1,000 and see if it's bigger than or less than negative 1. Okay, so you get h at 1,000 is equal to 3 minus 1,000 over 2 plus 1,000, which gives us negative 0.995. Is that bigger than or less than negative 1? So it is greater than negative 1, which means as x approaches positive infinity, y approaches negative 1 from above. Remember, the more negative you get, it becomes less. The least negative you get, so the more positive you go to, because negative 0.995 is to the right of negative 1, it is bigger than negative 1. And we're going to do h of negative 1,000 is equal to 3 minus negative 1,000 over 2 plus negative 1,000, which gives us negative 1.005. Is that less than or greater than negative 1? So it's going to be less than negative 1, which means as x approaches negative infinity, y approaches negative 1 from below. Okay, so at the end there are some key concepts, but remember to help you draw these graphs, really focus on the x and y intercepts, where the graph crosses the horizontal asymptote if it does, but more specifically the behaviors around the vertical asymptote. That will ultimately help you graph these reciprocal functions. Okay, so hopefully that wasn't too much information for the day. Remember, tomorrow cohort B are in class.